Okay, 2011 number 4. No calculators on this one or the rest of them on this test for that matter. Um, okay, f is continuous. Defined on this interval, f is 2 quarter circles. So these are quarter circles, and then one line segment. G is given by this function right here. So it's 2x plus that, and you really don't have to understand this, except this is like the area under f, and then I'm adding 2x to it. Don't really know what that looks like. I don't know if I need to at the moment. So let's see if we can do this. Find or see how much we can do without worrying about what it looks like yet. G of -3. Well, g of -3 is 2 times -3 plus the integral from 0 to -3 of f of t dt. So that's going to be -6 plus the integral from 0 to -3. 0 to -3. Well, that's just going to be I'm going 0 to -3. That's I'm going 0 to 3. That's what I'm thinking. Yikes. That's going to be minus the integral from -3 to 0 f of t dt, and -3 to 0. Well, that's this quarter circle of radius 3. So that's going to be -6 minus the area of a circle is pi r squared. Pi times 3 squared is 9, divided by 4 because it's a fourth of the circle. So my answer is going to be -6 minus 9/4 pi. Okay, that's the first part of A. That's g of -3. G prime of x. G prime of x. The nice thing is sometimes these work out really fast, sometimes they don't. G prime is the derivative. Here I'm looking down here. The derivative is 2 plus, and then, this is a fundamental theorem of calculus. The derivative of that, I just plug x into the function. It's just f of x. And g prime of 3 then is 2 plus f of 3, which is 2 plus, and f of 3 is, since this is f, 1, 2, 3, f of 3 is -3, is -1. Is that right? F of 3. Oh, it's g prime of -3. Oops. So that's a -3, -3. G prime of -3 is 0. So that would be 0. I knew something didn't look right. Now it's getting late on my side too. Okay, so there's A. B. Determine the x-coordinate of the point at which G has an absolute maximum on the interval. Justify your answer. So where does G have a maximum? Well, to find a maximum, I want to have to figure out where G prime of x equals 0. Well, that means solving this equation right here. So G prime of x equals 0 when f of x equals -2, right? Okay, because that's up here. Look at when that's equal to 0, then I just subtract the 2, of course, when f of x is -2. Now, where is f of x equal to -2? That's this guy right here, so you have to go up and figure out what is this. I'm going to make this red. So this is -2. What is this point right here? I have no idea right now. You're going to have to write the equation of this line and figure that out. Well, what's the slope of this line? And you got to do this quick. 1, 2, 3, 4, 5, 6 over 1, 2, 3. So the slope of this line is, if I go down 6 and over 3, is is negative 2, so the equation of this line is y equals negative 2x, the y-intercept is 3 plus 3. So if y is negative 2 equals negative 2x plus 3, and I subtract the 3, I get negative 5 equals negative 2x. So x must be 5 over 2, or 2 1/2. Okay, that's 5/2, and that's negative 2. Okay, so when f of x is negative 2, x is 5/2. Okay, let's go back to green. Okay, so now, how do I determine if I have to determine if that's a maximum? Okay, so let's just look at our little number line here. 5/2. For numbers to the left of 5/2, I have to determine what is g prime. Okay, numbers to the left. So pick a number to the left of 5/2, say 1. Okay, what can I say about g prime? And then numbers to the right. So pick a number to the left of g prime, so say 1. G prime of 1 is 2 plus f of x. That's always going to be, well, anything to the left here is going to be bigger than 2, so this is always going to be, or bigger than negative 2, so this is always going to be positive. And anything bigger to the right, all these numbers down here are less than negative 2. So 2 plus a negative 3, for instance, this is going to be negative numbers. Negative. So I can go ahead and make this argument, since g prime changes from positive to negative at x equals 5/2. X equals 5/2 is an absolute positive negative maximum. I don't need to check the endpoints because it's always, think about the curve, it's always increasing and then it's always decreasing. The endpoints are going to be definitely at the bottom here, so I don't even need to worry about those. Okay, so we're good on that one. Okay, C. Alright, I'm going to need the graph on this one. C. Find all points for which the graph of G has a point of inflection. Okay, G has an inflection point if G double prime changes sign, right? So if G double prime goes from positive to negative or negative to positive is what we're looking at. I have no idea what G double prime looks like, but I do know this. Go back up to here. G double prime equals f prime. What do you know about f prime though? Look at the curve. F prime is positive, positive, positive. I'm up here on the curve. F prime is positive, 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 undefined, negative all the way down. Okay, so f prime changes sign right at 0, and since f prime and g double prime are the same, it changes sign at 0. So g double prime equals f prime changes sign at x equals 0. So G has a point of inflection at x equals 0. Okay, and I can't just say it has a point of inflection at x equals 0 unless I state that G double prime equals f prime, and that I am allowed to read off the graph because the graph's given. Okay, and then D, we'll try to squeeze D in here. Let me erase this a little bit. Okay, D says this: find the average rate of change, not the average value, but the average rate of change on that interval, and the average rate of change is going to be this. F of 3, that's the slope of the secant line, right? Minus f of negative 4 over 3 minus negative 4. Okay, so we've got that, and if I do that, I'm going to end up getting negative 2 over 7. Okay, so that's my average rate of change. That's the slope of the secant line. Oops. That's the average rate of change of f. So if this is f, I'm going to go ahead and draw that in a different color, in this gray color. So from here to here, that's going to be this guy right here. Now remember what the mean value theorem says. This is a good real review. The mean value theorem right down here, let me make this bigger, says that there is some point on the curve that I should be able to draw a tangent line to and have it be parallel to this. But clearly there is no point on this curve that I can draw a tangent line to and have it be parallel to it. Why not? Why is this not a contradiction? That's what they're asking you to explain. What's the big deal here? What condition am I missing that has to be satisfied here? Yeah, you got it. The condition is f must be differentiable for the mean value theorem to apply, and f is not differentiable at x equals 0 or x equals negative 3. Since it has a vertical tangent right there, it's not differentiable. But it's clearly not differentiable there either, right? Because what does my tangent line look like? There isn't one. Okay, so makes sense. There you go. Good job. Tough problem.